right, so in the notes for A4, we're going to be doing problems involving trigonometry. The first part of the notes here has some reminders about sine, cosine, tangent, and then cosecant, secant, and cotangent. So those trig ratios that you need to know. All right, moving on to some practice problems. So the first one here says, consider this right triangle. What is the ratio equivalent to tangent of theta? So you want to start by circling your reference angle, and then you'll recall that tangent is opposite over adjacent. In this triangle, the 12 is the side that's opposite theta, and the 5 is the side that is adjacent to theta. And so tangent is equal to opposite over adjacent, and so that gives us enough information to answer the question. So the tangent of angle theta would be equal to 12 over 5, opposite over adjacent. Tangent does not use the hypotenuse, so the value 13 is not used in this question. Moving along, we have a similar question. This one says, consider this right triangle. What is the ratio equivalent to sine of theta? So again, you want to start by circling your reference angle, and then you want to recall that sine is opposite over hypotenuse. And so in this triangle, the x plus 2 is the opposite side, and then the 2x minus 1, that's the hypotenuse. So once I've identified the two sides that are going to be used in my trig ratio, I have enough to answer the question. So the sine of angle theta is equal to x plus 2, that's the opposite side, over 2x minus 1, that's the hypotenuse. Notice that the x plus 5 is the adjacent side, and in the sine ratio, adjacent is not used, so we just don't use the x plus 5 in our answer. All right, on this next question here, it says, suppose that angle E and angle G are the acute angles. Remember that an acute angle is an angle that's between 0 and 90 degrees. Suppose angle E and angle G are the acute angles in triangle EFG. If the sine of angle E is equal to 17 over 21, what is the cosine of the other acute angles? So it might help us to start by drawing a right triangle. All right, so here once I have that triangle drawn, I want to put letters on the triangle, so it's triangle EFG. It says that E and G are the acute angles, so we'll make sure that we label angle F as the right angle. I'll make a note here that it doesn't matter whether E or G go where I place them or if they were switched with one another. You just want to make sure that neither of them is labeled as the right angle. So we're starting with angle E, and so if the sine of angle E is 17 over 21, that means that angle E would be your reference angle. The 17 in the sine ratio would be opposite, and the 21 in the sine ratio would be hypotenuse. So the 17 would go opposite the E, and the 21 would go on the hypotenuse. And so that places those two numbers in the correct spot. Sometimes on these questions, you have to then do the Pythagorean theorem to solve for this side over here, the side that's missing. But in this question, we actually don't end up needing to do that based off of what we're being asked to do. The next part of the question asks us to figure out what's the cosine of angle G. So I'm going to do this in a different color. Now angle G becomes your reference angle, which means that the side that is opposite and the side that is adjacent to angle G is different than it was when we did angle E. Let me show you what I mean. So on this picture, for cosine, we know we need adjacent and hypotenuse. And so the 17, which was opposite angle E, is actually adjacent to angle G. So we have the adjacent side that we need to write cosine. And then the 21, that was the hypotenuse for angle E, that's also still the hypotenuse for angle G. And so on this particular question, it turns out that we don't have to solve for that missing side over here that was never labeled in the picture because we have the two numbers that we need. And so for this question, the cosine of angle G is also 17 over 21. So it's actually the same as the sine of angle E. We didn't need to solve for the third side. All right, on the next example, it says, consider the following right triangle. Determine which of the following expressions can be used to find the length of side AB. So this side over here, side AB, I'm going to call it X. That's the side that we're going to be solving for in this question. I'm given 5 different expressions, and I'm trying to figure out which one of them are set up correctly and which ones of them are set up incorrectly that I can or can't use to solve the question. 3 of the answer choices use angle C as the reference angle, and then 2 of the answer choices use angle A as the reference angle. So I'll start with angle C, and I'm going to do the work for this one in blue. So with angle C being my reference angle, the X is opposite, the 31 is the hypotenuse, and the 25 is the adjacent side. These labels for opposite and adjacent will switch when I switch to having angle A be my reference angle. So the first one says 31 times the sine of angle C. So I need to figure out if that includes the right numbers and the right trig ratio that I could use to solve for X. And to do that, I'm going to set up the equation that I would use to solve. So if I were using angle C as my reference angle with sine, I would be using X, the opposite side, and the 31, the hypotenuse. So it would say the sine of angle C is equal to X over 31. And then to get the X all by itself, I would need to multiply both sides by 31. And so for this question, I would get 31 times the sine of angle C is equal to X. So looking at the way that answer A is written, answer A is true. That expression would allow me to solve correctly for the side that I have labeled X, that's side AB. So that's the side that I'm looking for. Moving on to the next question, this one uses cosine, still with angle C as the reference angle. So cosine uses adjacent adjacent and hypotenuse. So for this one, the equation that I would set up would say the cosine of angle C is equal to adjacent, so 25 over hypotenuse 31. I would not be able to solve for x, the missing side, for side AB because I don't have that side included as a part of my equation. So the answer for B would be false. That one does not work. The third one, letter C, says 25 times the tangent of angle C. And so let's see, for this one, tangent would be opposite and adjacent. So the tangent of angle C would be equal to opposite, so x over 25. And then to get the x all by itself, I would times both sides by 25. And so for this one, I would get 25 times the tangent of angle C is equal to x. And so looking at the way that answer C is written, answer C would be true because that's the correct expression. Moving on to do the work for D and E, I'm going to switch to a different color because in these two, we're using angle A as our reference angle. And so if it helps you, you can actually scribble out the words opposite and adjacent because once you switch your reference angle, the side that was opposite the other acute angle becomes the adjacent side, and then the side that was adjacent to the other acute angle becomes the opposite side. The hypotenuse stays the hypotenuse though. Here, I'll trace over that so that you see that that's the same. So the hypotenuse is still the hypotenuse, no matter which of the acute angles you're using as your reference angle. So let's see, for letter D, it says 31 times the cosine of angle A. So if I'm using angle A as my reference angle, and if I'm using cosine, I'm going to need to use the x and the 31. So the cosine of angle A is equal to x divided by 31, and then I would times both sides by 31 to get the x all by itself. So 31 times the cosine of angle A is equal to x, and so D would also be true. And then lastly, the next one also uses angle A, but it uses tangent. And so for this one, I'm going to say that the tangent of angle A is equal to, and tangent is opposite over adjacent. So for this one, it's going to be 25 over x. I would need to multiply both sides by x to move the x out of the denominator. So x times the tangent of angle A is equal to 25. And then to finish, I would need to divide both sides by the tangent of angle A. So I would get x is equal to 25 divided by the tangent of angle A. And comparing that to my answers for this final question for E, I would say that E is false because those expressions are not equivalent to one another. All right, on the next example, it says a person is standing near the base of a building and tries to measure the angle of elevation to the top. They're unable to get an accurate measurement, but they determine that the angle of elevation is between 40 degrees and 60 degrees. Decide which of the following values is a reasonable estimate for the length of a ladder needed to reach a window that's 24 feet off the ground. Select all that apply. And so in this problem, we're going to apply trig to solve two different equations to figure out both the greatest and the least values that the length of the ladder could be. And then based on our answer range, we'll use that to answer the question. I'm going to start by drawing two triangles because I'm going to need to solve for 40 degrees and 60 degrees. All right, so here I have my two right triangles. Keep in mind it doesn't matter exactly which way you face your right triangles when you're drawing the picture. The hypotenuse should look like it's going up because the ladder would be leaning against the building. The building is over here on the right-hand side, and then the ladder is the hypotenuse of the triangle. So in the first question, the reference angle we're going to place as 40 degrees. The window is 24 feet off the ground, and you're trying to figure out the length of the ladder. In the second example, the window is still 24 feet off the ground. You're still trying to figure out the length of the ladder, but here the upper range for the reference angle is 60 degrees. So I'll need to solve these separately. Circle my reference angle. The 24 is opposite and the x is the hypotenuse. And so that's how I'll decide that on both of these, I'm going to be using sine to solve. But again, I'll solve them separately. So the sine of 40 degrees is equal to opposite over hypotenuse. I'll multiply both sides by x. And then to finish the question, I'm going to divide both sides by the sine of 40. It looks like all of my answers are rounded to one decimal place, and so I'll also round this answer to one decimal place. Making sure that your calculator's in degree mode, typing this in, you get x is equal to 37.3 feet. And then I'll solve the next question similarly. So the sine of 60 degrees would be equal to opposite 24 over x, which is the hypotenuse, multiply both sides by x. And then I'll divide both sides by the sine of 60 to finish. And so here I'll get that the length is 27.7 feet. So interpreting these two answers, I want to make sure I understand what I'm doing before I start checking off the select all that apply question. If the angle were 40 degrees, the ladder would need to be 37.3 feet. If the angle were 60 degrees, the length of the ladder could be 27.7 feet. And so your answer to the question are going to be all of the numbers that fall within that range. And so your answers will be any values that are between 27.7 and 37.3 feet. So looking at the list, the first answer choice is not possible because the ladder would be too short. The second ladder would still be too short. The third ladder would be just long enough, so that would be a yes. The fourth one would be in the range, so that one would be a yes. The next letter would be too long, and then the last letter would be too long. And so again, based on the fact that the angle of elevation is between 40 and 60 degrees, only these two values here, 27.7 and 29.5 feet, would work as lengths of the ladder. All right, moving on. So in this next example, we're trying to find the measure of angle A. So we'll circle our reference angle. The 35 is opposite angle A, and the 17 is adjacent to angle A. And so because I have opposite and adjacent, I know I'm going to be using tangent. And so I'll set up my trig ratio to solve. So I'll say that the tangent of angle A is equal to 35 over 17. Now notice in this question what's different, you're not solving for one of the side lengths on the triangle, you're trying to figure out how big the angle itself is. And so I'll need to use inverse trig to solve this one. So I'll take tan inverse of both sides. Remember, tan inverse crosses out with tangent. And so what you're left over with is that angle A is equal to tan inverse 35 divided by 17. And so type that into your calculator, making sure that your calculator's in degree mode. It says to round your answer to the nearest whole degree. And so for this one, the measure of angle A is going to be approximately 64 degrees. Depending on your familiarity with right triangles, you might notice that angle A is opposite the longer of the two legs. So it makes sense that your answer would be greater than 45 degrees. It still has to be less than 90 because there can only be one 90-degree angle in a right triangle, but it would have to be the larger of the two acute angles in the right triangle because it's opposite the larger side. All right, on this next one, so drawing a picture for this one is a little bit tricky. I'm no artist, but something like this will get the job done. So in this picture, the platform's on the left, the truck is on the right. I can continue to label the picture with the other information that was given to me in the question. The truck can get no closer than 3 feet to the platform, so this distance would be 3. The truck bed is 1.5 feet higher than the loading platform, so this side would be 1.5. And I'm trying to solve for the angle of elevation from the platform to the truck. So I'm trying to solve for the angle that I just labeled theta here in the picture. Circle my reference angle. The 1.5 is opposite, the 3 is adjacent, and so that's how I decide that for this one I'm going to be using tangent. And so the tangent of that unknown angle is equal to 1.5, the opposite side, divided by 3, the adjacent side. I'm trying to solve for the measure of the angle, so I'll use tan inverse on both sides. Remember that tan inverse crosses out with tangent, and so I get theta is equal to tan inverse of 1.5 over 3. Typing that into your calculator, making sure that your calculator is in degree mode, you get theta is equal to, it doesn't say what to round to on this one. I'll round it to the nearest whole degree, so theta is equal to approximately 27 degrees. Again, depending on your familiarity with right triangles, you might notice that the angle theta is opposite the shorter side. And so you would expect that your answer would be less than 45 degrees. It has to be greater than 0 because you can't have an angle smaller than 0 inside a triangle. But 27 degrees, you would want it to be less than 45, and it is. So it's kind of like a check for the question. All right, here in this next question, the way that you do the problem will certainly depend on whether or not you have access to a calculator. I'm going to start by drawing a picture for this one. All right, so here in the triangle that I'm given, angle C is labeled on the picture. Angle C is going to be my reference angle. And in the picture, the side across from the C would be the opposite side. The side that's adjacent to the C here would be the adjacent side. And then remember, the hypotenuse always remains the hypotenuse. And so this question is asking you to compare the cosine of angle C to the sine of angle C for each of these different possible measures for angle C. And it wants you to figure out for which of these angle measures will the cosine of the angle be greater than the sine of the angle. There's not math to work out for this one, but you do have to reason the different angle measures. So one by one, I'm going to put the numbers in and I'm going to talk through the answer to the question. If angle C were 10 degrees, that means that the other acute angle would have to be 80 degrees because we know that all three of the angles in a triangle add up to 180, and we know that the box in the corner means that that angle is the right angle. That angle is 90 degrees. So in this picture, the side opposite the 80 degrees is the adjacent side, and the side opposite the 10 degrees is the opposite side. The adjacent side would be larger, and the opposite side would be smaller because the 80 degrees is larger than the 10 degrees. And so this is the theorem about triangles that we're applying here. So in this picture, when I did cosine of the angle, cosine would be adjacent over hypotenuse. I'd be putting a larger number in the top of that fraction. When I did the sine of angle C, I'd be putting the opposite over hypotenuse, and that would put a smaller number in the top of the fraction. And so for this question, if the angle was 10 degrees, like it is here in the picture, 10 degrees would be a yes, because the cosine of that angle would be greater than the sine of that angle. And so going through to answer the rest of the questions, you just need to switch out the numbers. You don't actually have to switch out any of the labels on the picture just yet. So I very carefully erased the angle measures, and now I'll do the same for 20. So if angle C were 20 degrees, that means that the other acute angle would have to be 70 degrees, and then the smaller and larger labels would still apply. When I do the cosine of 20 degrees, cosine would be adjacent over hypotenuse, so the larger number would be in the top of the fraction. Sine would be opposite over hypotenuse, so it would be the smaller number in the top of the fraction. And so 20 degrees would also produce a correct yes answer to the question because the cosine would be greater than the sine. Moving on to the next value that we're given. So on this one, angle C is 30 degrees, which means the other acute angle would need to be 60 degrees. And here the smaller and larger labels would still apply because 30 degrees is still smaller than 60 degrees. And so the answer to this next question would also be yes. When I do cosine, it would be adjacent over hypotenuse, and that fraction would be bigger than when I do sine, opposite over hypotenuse. And so you might be starting to see the pattern. In all of those three first problems, angle C was smaller than the other acute angle in the triangle. So notice what happens that changes when it's 50 degrees. When angle C is 50 degrees, the other acute angle would need to be 40 degrees, and then these labels would need to change. Now the 50 degrees is larger than the 40 degrees, so the opposite side becomes the larger side, and the adjacent side becomes the smaller of the two sides. And so answering the question for 50, the cosine of the angle would be smaller over hypotenuse, not larger over hypotenuse. And so 50 would not be an answer to the question because cosine would be smaller than sine. And so looking ahead, you can go through and you can plug in 60. For 60 degrees, angle C would be 60, the other angle would be 30, and so that would also be a no. And then when you plug in a 70, angle C would be 70, the other angle would be 20, and so that would also be a no. And so all three of those are no's because in those three examples, angle C is the larger of the two angles, which means that sine would be greater than cosine for those final three examples. All right, here in this next example, it says determine if each equation is true or false. And so the way that you do this problem will definitely depend on if you have a calculator or not, because with a calculator, you can simply type in degree mode, sine of 330, sine of 210, and determine if they are the same or if they are different. So if you have a calculator, it's a very quick question. However, chances are when you're doing this problem, you're not going to be having access to a calculator. And so there's a couple of things that can help you when it comes to answering it. We're trying to figure out if these values are equal for these given degree measures. One thing that might help you before I start to answer the question and draw reference angles is that on the xy plane, when you move to the right, x's are positive, and when you move to the left, x's are negative. When you move up, y's are positive, and when you move down, y's are negative. And so knowing that information, reminding yourself of that information can be helpful because when it comes to trig ratios, in quadrant 1, that's this quadrant right here, all of them, sine, cosine, and tangent, everything is positive. Any angle whose terminal side is in quadrant 2, sine is positive, but cosine and tangent are both negative. In quadrant 3, tangent is the one whose value is positive, and then sine and cosine are both negative. And then lastly, in quadrant 4, cosine is the one whose value is positive, and then sine and tangent are both negative. So knowing that information might help you when it comes to answering these questions because some of these have the same number value, they're just different signs. All right, so here we go. So for the first one, the sine of 330 degrees would put you over here in quadrant 4. The reference angle would be 30 degrees, and I'm finding sine, which is opposite, so negative 1/2 over hypotenuse. For the second angle in the question, it's the sine of 210 degrees, so 210 degrees would put you over here in quadrant 3. The reference angle would also be 30, and again, it's sine, so it would be opposite over hypotenuse. And so for this first question, the sine of 330 degrees is going to be negative 1/2 divided by 1, so it would be negative 1/2, and the sine of 210 degrees is going to be negative 1/2 divided by 1, so also negative 1/2. And so these two match, so the answer to the question would be true, they are equal to one another. All right, moving on to B, the tangent of 405 degrees, that's going to put you in quadrant 1. Your reference angle here would be 45 degrees, and you're doing tangent, so tangent is opposite over adjacent. And for the second angle, it's 495 degrees, that puts you in quadrant 2. The reference angle here is also 45 degrees, and again, you're doing tangent, so opposite over adjacent. So the tangent of 405 degrees would be opposite over adjacent. The square root of 2 over 2 divided by the square root of 2 over 2 would give you positive 1. And then the tangent of 495 degrees would be also opposite over adjacent. So the square root of 2 over 2 divided by negative the square root of 2 over 2, which would give you negative 1. And so the answer for B is no, it's false. Those values are not equal to one another. Moving on to question C, the cosine of 20 degrees. Cosine would be adjacent over hypotenuse. So the hypotenuse is going to be positive 1. The adjacent side right here, just squeeze in a little plus sign because you know that it would be a positive number. The cosine of negative 20 degrees would be right here in quadrant 4. The reference angle would also be 20 degrees. Cosine is adjacent over hypotenuse. So again, the hypotenuse is 1, and then the adjacent side is going to be right there, still that positive value. That value cannot be determined because 20 degrees does not produce a special right triangle. And so for this one, the cosine of 20 degrees would be that positive number, whatever it is, over 1. And then when you do the cosine of negative 20 degrees, it would be that same positive number divided by 1. And so these two would be equivalent to one another. So the answer for C is true. And then the last problem in this set, negative 240 degrees puts you in quadrant 2. Your reference angle here is 60 degrees. You're finding tangent, so you need opposite and adjacent. So the square root of 3 over 2, and then negative 1/2. And then your other angle measure is the tangent of 300. 300 puts you in quadrant 4. Your reference angle is also 60 degrees. And here you're also finding tangent, so opposite and adjacent. And so here the tangent of negative 240 degrees would be the square root of 3 over 2 divided by negative 1/2. You would copy dot flip, the 2's would cross out, and so you get negative the square root of 3. And then when you do this last one, the tangent of 300 degrees, you're going to get negative the square root of 3 over 2 divided by positive 1/2. You would again copy dot flip, the 2's would cross out, and for this one you would also get negative the square root of 3. And so the answer for this question is yes, they are equivalent, and so the answer for D is true. The final example on this page gives you some practice with graphing angles that are given to you in radian measure and then evaluating the trig expressions for each one. Remember that you can convert from radian measure into degree measure first if you feel more comfortable with degree measure. So here for my first one, the cosine of pi over 4. Pi over 4 is the same as 45 degrees. This angle is going to be in quadrant 1. Here's my reference angle labeled, and I need cosine. So for cosine, I need adjacent over hypotenuse. So here the cosine of pi over 4 radians is equal to adjacent over hypotenuse. And so I get that the cosine of pi over 4 radians is equal to the square root of 2 over 2. On B, pi over 3 is also in quadrant 1. Here my reference angle is 60 degrees, and I'm doing sine. So for sine, I need opposite and hypotenuse. So here the sine of pi over 3 radians is equal to opposite over hypotenuse. And so the sine of pi over 3 radians is equal to the square root of 3 over 2. Moving along to the next question, 3 pi over 4 is in quadrant 2. Here my reference angle is 45 degrees. And then for cosine, I need adjacent and hypotenuse. And so the cosine of 3 pi over 4 radians is equal to adjacent, negative the square root of 2 over 2 over hypotenuse. And so the cosine of 3 pi over 4 radians is equal to negative the square root of 2 over 2. Here again, also working in quadrant 2, so tangent of 2 pi over 3, 2 pi over 3 is in quadrant 2. The reference angle for this one is 60 degrees. And for tangent, I need opposite and adjacent. And so the tangent of 2 pi over 3 radians is equal to opposite, so the square root of 3 over 2 divided by adjacent, negative 1/2. And when you copy dot flip, the 2's in the denominators will cross out with one another. And so for this one, you'll get that the tangent of 2 pi over 3 radians is equal to negative the square root of 3. On E, 17 pi over 6 is a full rotation plus an additional partial rotation. And so 17 pi over 6 is going to stop in quadrant 2. The reference angle is 30 degrees. And for cosine, I need adjacent and hypotenuse. So the cosine of 17 pi over 6 is going to be equal to the adjacent side, so negative the square root of 3 over 2, and then divided by the hypotenuse, which is 1. And so the cosine of 17 pi over 6 radians will be equal to negative the square root of 3 over 2. And then lastly, negative 5 pi over 6 radians finishes in quadrant 3. My reference angle here is 30 degrees. And for sine, I'm going to need opposite and hypotenuse. So the sine of negative 5 pi over 6 radians is equal to negative 1/2. That's the opposite side divided by 1, the hypotenuse. And so for this one, I get that the sine of negative 5 pi over 6 radians is equal to negative 1/2.